Hello students, welcome to your channel Parivartan Physics. See, in today's video we'll see 3 marks important numericals from electromagnetic induction as many of you were requesting. In yesterday's videos we have seen 2 mark important numericals from electromagnetic induction as well as 2 mark important numericals from electric potential and capacitance. Right? According to the 3 blueprints as well as the 3 model papers released by the board, there is maximum possibility of getting a 3 mark numerical from electromagnetic induction. Right? So these numericals will help you in understanding and solving 3 mark numericals from electromagnetic induction. Okay, without delaying, let us begin with the session then with the problems. Okay, the first question is the magnetic flux through a coil of 10 turns changes with a time as pi is equal to t square minus 2t plus 4 Weber. Find the magnitude of the induced EMF at t is equal to 3 seconds. See, here they have given flux in the form of an equation which is time dependent, right? And they are asking us EMF. So if the flux is given in the form of a time dependent equation, you should differentiate it, you will get the EMF, correct? So EMF E is equal to, we are having the formula rate of change of magnetic flux d pi by dt. Clear? What is the equation of flux? This question is from question bank which has been released by the board for this year, right? Okay, this is t square plus 2t, minus 2t, t square minus 2t plus 4, t square minus 2t plus 4. You differentiate this, you will get it as 2t minus 2. Clear? So EMF E is equal to 2t minus 2. This much we will get. We want EMF at which second? At 3 seconds. So we want EMF at 3 seconds at t is equal to 3 seconds. We'll substitute t is equal to 3 seconds here. We'll get it as 2 into 3 minus 2. That is 2 into 3 is 6. 6 minus 2 will get the EMF as 4 volts. Right? So this much will be the EMF induced. This is for 1 turn. There are 10 turns in the coil. So if you want the EMF induced in the 10 turns, you multiply it by 10, you will get the EMF induced for the 10 turns. This is how we have to calculate the EMF. So remember, whenever the flux is given in the form of an equation, time dependent equation, you differentiate it, you will get EMF. Correct? We'll go to the next question then. A square loop of side 10 centimeter, side of the square loop is given, resistance 0.5 ohm is placed vertically in east-west plane. Vertically in east-west plane. A uniform magnetic field of 0.10 Tesla is set up across the plane in a northeast direction. The magnetic field is decreased to 0 in 0.70 seconds. Magnetic field 0 agidre. Eshittu 0.10 iddada 0 agidre. In 0.70 seconds, it has got reduced to 0. At a steady rate, determine the magnitudes of induced EMF and current. Here we have to calculate EMF as well as current. Both we have to calculate. Okay, since the natural directions have been mentioned in the question, take the natural directions. See, if this is north, then this will be south, right? If this is north, this will be south. And if this is east, this will be west, correct? Coil is placed in which direction? It has been placed in north, east-west plane. Okay, so the coil is placed in east-west plane. So here the coil is placed. So like this, the coil is placed now, right? Okay, it is like this. Next, magnetic field. In which direction the magnetic field is there? Magnetic field is in northeast direction. Where comes the northeast direction? This is north, this is east. So this is northeast direction. So in a northeast direction, the magnetic field is there. So the magnetic field is in this direction. This is the direction of magnetic field, right? What is the angle made by the direction of magnetic field with respect to the plane of the coil? With respect to the plane of the coil, the angle is 45 degree, or with respect to normal to the plane of the coil will also be 45 degree only. We are taking it as 45 degree because it is in northeast direction. It is in northeast direction. Clear? Okay, magnetic field is in this direction. The coil is kept in this direction. We have to calculate induced EMF as well as current. See, here the magnetic field is 0.10 Tesla and it will become 0 in 0.70 seconds. So what is changing here? Magnetic field is changing, right? So nodri, EMF induce agbekadre flux namagu change agbeku. To get EMF, flux has to change. Flux change agbekadre flux yatra mele depend. The flux is dependent on N, B, A cos theta. It means if number of turns changes, flux will change. If flux changes, EMF will get induced. If magnetic field changes, flux changes, EMF will get induced. If area changes, flux changes, EMF will get induced. If angle, orientation changes, flux changes, EMF will get induced. In this question, what is changing? Magnetic field is changing. From where to where? From 0.10 to 0.70. So I can write EMF, equation of EMF like this, NA cos theta, NA cos theta. I will apply d by dt for magnetic field because magnetic field is changing here, correct? So there is no number of turns given, you take it as 1. Area, side of the square is 10 centimeter, then area of the square will be 10 into 10, right? It means 100 centimeter square, this much will be the area. You take it in meter now, so centimeter square to meter square, 100 into 10 to the power minus 4 meter square, or simply I can write it as 10 to the power minus 2 meter square, correct? This much will be the area. Substitute that area here, 10 to the power minus 2 into cos, how much is the angle? Angle is 45 degree, so cos theta, theta is 45 degree, right? dB by dt, dB means change in magnetic field, dt means time taken to change the magnetic field. So change in magnetic field is 0.10 minus 0 divided by time taken is 0.70, correct? Okay, so this will be 10 to the power minus 2 into cos 45 degree means it will be 1 by root 2 into this will be 0.10 divided by 0.70. Andre idu 10 by 7, 10 by 70 andangre. So 10 ones are 10 sevens. So I will get it as 10 to the power minus 2 divided by 7 root 2 divided by 7 root 2. This much I will get. Let us calculate the value of this. Use the calculator so that you will get the accurate values. However, the calculator is allowed in the board. Okay, root 2 into 7. How much this is? 9.8994. 9.8994, right? 9.8994. Okay, next we will divide 1 divided by 9.8994. what I will get? 0.1010. So this is 0.1010 into 10 to the power minus 2 into 10 to the power minus 2. This I can write it as 1.010 into 10 to the power minus 3, or simply we can write it as 1 into 10 to the power minus 3 volts, right? So this much will be the EMF, or you can also write it as 1 millivolt also, 1 millivolt also, correct? So this is EMF. Next what we want? We want current, correct? We want current. So current I is equal to E divided by R. Why? By Ohm's law we know V is equal to I into R, then I is equal to V divided by R. What is V? V itself is taken as EMF here. EMF volt ಒಳಗಿರ್ತದೆ, potential difference volt ಒಳಗಿರ್ತದೆ, right? This is why we take I is equal to E divided by R. How much is E? E is 1 millivolt, 1 into 10 to the power minus 3 divided by R. R is 0.5, 0.5 means I can take it as half. So 2 will come to the numerator. So 2 into 10 to the power minus 3 ampere. This much will be the current, or simply I can write it as 2 milliampere. This much will be the current. Okay, we'll go to the next question then. See, the next question is the magnetic field inside a coil of length 0.5 meter and area of cross section 100 centimeter square. This is centimeter square. Power is 1.585 into 10 to the power minus 3 Tesla. What is the magnetic energy density inside the coil? Magnetic energy density inside the coil. Also calculate the magnetic energy stored by the coil. Okay, first thing is you have to calculate magnetic energy density inside the coil, and then you have to calculate magnetic energy of the by the coil stored in the coil. See, magnetic energy density is given by B square by 2 mu naught, formula in NPTEL, and magnetic energy can be calculated by magnetic energy density into volume. So these are the formulas you have to use. This is the question from question bank released by the board, right? Okay, first energy density now calculate ಮಾಡೋಣ. B square, B is 1.585 into 10 to the power minus 3 whole square divided by 2 into mu naught. Mu naught means it will be 4 pi into 10 to the power minus 7, right? Okay, now you simplify this. You have to simplify this. Okay, let us simplify. Okay, so 1.585 into 1.585, correct? Squaring that, I will get 2.512, right? 2.512 into 10 to the power minus 6 divided by 2 4s are 8, 8 into 3.142 into 10 to the power minus 7. Okay, so we will write it like this now. 2.512 divided by 8 into 3.142, that will be 25.5 25.136 into 10 to the power minus 1, minus 6 hoitu, right? So I will get it as this one, I will get it as, if I take 10 to the power minus 1 to the numerator, it will be 25.12 and this will be 25.13, right? Almost it will be equal to 1 joule, right? This much will be the energy. Okay, we got energy this much now, energy this much in energy density we got this much. So this is not joule, energy density, right? So density, energy density means joule per meter cube it has to be, right? Okay, next what we want magnetic energy. So magnetic energy means energy density into volume, energy density into volume. So this is energy density joule per meter cube, right? Joule per meter cube. Okay, next magnetic energy. Magnetic energy density 1 joule per meter cube we have got into volume. Volume means we have to take it as length into cross-sectional area. Length into cross-sectional area. So this is 1 into length. Length is 0.5 meter into area. Area is 100 centimeter square. So you take it in meter square. 100 centimeter square to meter square means 10 to the power minus 4. Okay, so this will be 0.5. 0.5, see, I will rate it as 0.5 into 10 to the power plus 2 10 to the power minus 4 means it will be 10 to the power minus 2. I can write it as 5 into 10 to the power minus 3. This is energy, so joule, or simply I can write it as 5 millijoule. 5 millijoule, right? So this is how we have to calculate the energy as well as energy density. Okay, we'll go to the next question then. So the next question is, a long solenoid with 15 turns per centimeter. See, 15 turns per centimeter they have given. So this is number of turns per centimeter. Small n, it is not capital N. So 15 turns per centimeter has a small loop of area 2 centimeter square. Area is given 2 centimeter square, correct? Placed inside the solenoid normal to its axis. If the current carried by the solenoid changes steadily from 2 ampere to 4 ampere in 0.1 seconds, right? 2 ampere to 4 ampere in 0.1 seconds, right? What is the induced EMF in the loop while the current is changing? Okay, we have to calculate EMF now. ಈಗಿಲ್ಲೇ ನೋಡ್ರಿ, ವಾಟ್ ದೇ ಹ್ಯಾವ್ ಟೋಲ್ಡ್, ದೇರ್ ಇಸ್ ಅ ಸಾಲಿನಾಯ್ಡ್. ಒಂದು ಸಾಲಿನಾಯ್ಡ್ ಅದ. ಈ ಸಾಲಿನಾಯ್ಡ್ ಒಳಗಡೆ ಒಂದು ಏನ್ ಮಾಡ್ಕೊಂಡಿದಾರಪ್ಪ ಅಂತಂದ್ರೆ ಸ್ಮಾಲ್ ಲೂಪ್ ಆಫ್ ಏರಿಯಾ 2 centimeter square is kept placed inside the solenoid. Okay, so there is a small loop here inside this. ಇದ್ರ ಒಳಗಡೆ ಒಂದು ಸ್ಮಾಲ್ ಲೂಪ್ ಅದ. ಈಗ ಈ ಲೂಪ್ ಒಳಗೆ ಇಲ್ಲೇನು ಒಳಗಡೆ ಲೂಪ್ ನಮ್ಗೆ ಇಟ್ಟಿದಾರಲ್ರಿ, ಈ ಲೂಪ್ ಒಳಗೆ ನಮಗೆ ಎಷ್ಟು EMF ಇಂಡ್ಯೂಸ್ ಆಗಿತ್ತು, that we have to calculate, right? That is what we have to calculate. So EMF induced is given by, we know very well, EMF induced is given by E is equal to d pi by dt. d pi by dt. Pi means it is NBA. Pi means it is NBA, correct? NBA cos theta. Il theta antu namagu 0 agtadri. So d by dt of NBA. Here number of turns in this loop is not given, right? Andre adanna ನಾವು 1 ಅಂತ ತಗೋಬೇಕು. So ille d by dt of b into a. d by dt of b into a. Now what is changing? What is changing here? Current is changing, right? Current is changing. See, ಈಗ ಇಲ್ಲೇನು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಅದ, ಆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಯಾವ ತರದ, ಇಲ್ಲೇನು ನಮಗೆ ಸಾಲಿನಾಯ್ಡ್ ಅದ, ಸಾಲಿನಾಯ್ಡ್ ಒಳಗೆ ನಮಗೆ ಕರೆಂಟ್ ಪಾಸ್ ಆಗ್ತಿರ್ತದ್ರಿ, ಸಾಲಿನಾಯ್ಡ್ ಒಳಗೆ ಕರೆಂಟ್ ಪಾಸ್ ಆಗ್ತಿರ್ತದ, ಅದರಿಂದಾಗಿ ನಮಗೆ ಇಲ್ಲೊಂದು ಸಾಲಿನಾಯ್ಡ್ ಒಳಗಡೆ ಒಂದು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗಿರ್ತದೆ. ಆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ವಿಲ್ ಬಿ ಪ್ರೊಡ್ಯೂಸ್ಡ್. ಆ ಸಾಲಿನಾಯ್ಡ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಒಳಗಡೆ ಈ ಲೂಪ್ ಅನ್ನ ನಾವು ಇಟ್ಟುಕೊಂಡಿದ್ದೀವಿ. ದಿಸ್ ಲೂಪ್ ವಿ ಹ್ಯಾವ್ ಕೆಪ್ಟ್, ಕರೆಕ್ಟ್? ಸೊ the flux of this loop kept inside the solenoid will change due to the magnetic field of solenoid, and hence the EMF will get induced. So ಇಲ್ಲಿ ನೀವು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಯಾವ ತರ ತಗೋಬೇಕಂದ್ರೆ ಸಾಲಿನಾಯ್ಡ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ನೀವು ತಗೋಬೇಕು. ಸಾಲಿನಾಯ್ಡ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಯಾಕೆ ಚೇಂಜ್ ಆಗತ್ತಂದ್ರೆ ಬಿಕಾಸ್ ದ ಕರೆಂಟ್ ಇನ್ ದ ಸಾಲಿನಾಯ್ಡ್ ಇಸ್ ಚೇಂಜಿಂಗ್. ವಾಟ್ ಇಸ್ ದ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಫಾರ್ solenoid's magnetic field? It is mu naught Ni. Mu naught Ni. That is what I will substitute here. d by dt of magnetic field of solenoid mu naught Ni into area. Among these things, what is changing? Mu naught is already constant, N is number of turns per unit length, current area. Current is changing, right? So I can write it like this now, mu naught N into A into di divided by dt. Like this we can write. Mu naught means it is 4 pi into 10 to the power minus 7. Correct? 4 pi into 10 to the power minus 7. Small n is 15 turns per centimeter. You have to take it in meter now. This centimeter the meter convert ಮಾಡ್ಕೋಬೇಕಾದ್ರೆ ನೀವು ಇದು 10 to the power minus 2 ತಗೋಬೇಕು. 10 to the power minus 2 ಮೇಲ್ಗಡೆ ಬಂದ್ರೆ it will be 1500 turns per meter. 1500 turns per meter. ಇದು ಸೆಂಟಿಮೀಟರ್ ಸ್ಕ್ವೇರ್ ಒಳಗದೆ, ಇದನ್ನ ನೀವು ಮೀಟರ್ ಸ್ಕ್ವೇರ್ ಒಳಗೆ ತಗೋಬೇಕಾದ್ರೆ 2 into 10 to the power minus 4 meter square. Correct? Now substitute those things here. N is 1500. N is 1500 into area is 2 into 10 to the power minus 4. 2 into 10 to the power minus 4 into change in current. Current was 2 ampere, it has become 4 ampere. 4 minus 2 is 2. Change in current is 2 divided by time taken to change 0.1. 0.1 second andre 10 to the power minus 1 anta na tagoteve. Correct? Okay, what all we will get now? 10 to the power minus 1 from this, minus 1 from this will get cancelled. We'll get it as, see, 4 into pi into 1500 into 2 into 2. Okay, let us multiply all these things. 4 into pi 3.142 into 1500 into 1500 into 2 into 2. Right? I will get it as 75408. Okay, this is 75408 into 10 to the power minus 10. I will get 10 to the power minus 10. Correct? So this much I will get. If you want, you can change the power of the 10 now. So I can write it as 7.5408 into 10 to the power minus 6 volt. Right? 10 to the power minus 6 volt, or you can write it as micro volt. Correct? So mu naught means 4 pi into 10 to the power minus 7. N is 1500. Area is 2 into 10 to the power minus 4. 2 divided by 10 to the power minus 1. This will be minus 3. Minus 3 minus 7 will be minus 10. Okay. So we have multiplied 4 pi. I will just check it once more. 4 into 3.142. 4 pi. Sorry. 4 into 3.142 into 4 pi aita. Next 1500 into 1500 into 2 into 2, 4. So this is 4. 75402. Okay. So that's all about the EMF. This much EMF, we'll get it. Okay, we'll go to one more question. A rectangular wire loop of sides 8 cm and 2 cm with small cut in the moving out of region of uniform magnetic field of magnitude 0.3 Tesla, directed normal to the loop. What is the EMF developed across the cut if the velocity of the loop is 1 cm per second in a direction normal to the longer side? See, ille namagondu rectangular loop adu. We are having a rectangular loop and there is a small cut. Here we are having the cut. This side of the loop is 8 cm. This side of the loop is 8 cm and this side of the loop is 2 cm. 2 cm, right? Magnetic field is directed normal to the loop. For example, let me say the magnetic field is in this direction. It is 0.3 Tesla. Normal to the loop. Under loop perpendicular magnetic field. Inwards irbodu, outwards irbodu. And this is moving with a velocity of 1 cm per second. Okay, the coil is moving with a velocity of 1 cm per second. Well, this much is given. We have to calculate what? We have to calculate EMF developed across the cut if the velocity of the loop is 1 cm per second in a direction normal to the longer side. So here, see, EMF will be induced in the longer side of the coil, right? Not in the shorter side of the coil. Why? Because the longer side of the coil will cut the magnetic field perpendicularly. This shorter side namak magnetic field in perpendicular cut manangilla, right? Yav side of the coil namak magnetic field in perpendicularly cut ಮಾಡ್ತದೆ, only in that side of the coil the EMF will get induced, right? What is that EMF called as? Motional EMF. That's why we have to calculate the EMF by using the formula E is equal to B into L into V. How much is B? B is 0.3. How much is length? Length is 8 cm. You take the longer side because it is cutting the magnetic field perpendicularly. It is 8 cm. I will take it in meter. 8 into 10 to the power minus 2 into velocity 1 cm per second. You take it in meter. 1 into 10 to the power minus 2. Okay, we'll get it as 0.3. Otherwise, 3 into 8 into 1 into 10 to the power minus 5 anta baritini. 10 to the power minus 2 will be minus 4. Minus 4 is then 0.3, the 0.3, the 3 anta tagondini, so minus 5. So 3 into 8 will be 24 into 10 to the power minus 5. So I can write it as 0.24 into 10 to the power minus 3 volts, or simply I can write it as 0.24 millivolts. So this much will be the EMF induced, right? So that's all about the important 3-mark numericals from electromagnetic induction. So dear students, if you like the content of this channel, please don't forget to hit the subscribe button, and please share the video and share the channel with your friends, right? Thank you so much for watching the video and supporting the channel. Please keep watching and supporting the channel. Thank you. We'll meet again in the next video. Okay.